Hi everyone, now we will continue to introduce how to do the hypothesis test. We don't know the two population means condition. So just like what we learned before, the population mean we don't know, and you want to do the hypothesis test. There is one tail and two tail case. Okay, so one tail case and two tail case, you will find they may larger or less or equal to a specific value. So how to distinguish one tail or two tail test case? You can check the clip we introduced for the interval estimation. I had explained it in that clip. So if you know the forms for the hypothesis test, you can also try to calculate the distribution for it, because it's an population mean unknown condition. So we have to use the t-distribution. And the t-distribution, we have to calculate the test statistic. Okay, so it will follow the t-distribution. So you can check the formula for the test statistic, that is t. Okay, such formula. Okay, so here we can use an example question from your textbook. That is, today a company, they are consider a new software to think about if such software can help them to reduce the time, okay, for their service. So they will to think about the benefit from the new software package or from the original one. Okay, so today they do the hypothesis test. So first they use 12 analysts. They use the current technology. Okay, and the other group, that is 12 analysts, they are trained by using the new software. Then the researcher, they will to evaluate, okay, whether the group use the original one technology or use the new software, which one will provide a shorter completion time for them. Okay, so based on such group question, you can do the hypothesis test. Okay, so we can use mu1 on behalf the mean of the project completion time by using the current technology, and use mu2 as a mean of the project completion time by using the new software package. So then we will do the hypothesis test based on the steps we had learned before. That is, the first one, we will develop the hypothesis. Okay, so we will say if the two different software, will they have the same efficiency or the completion time for us, if yes or not. Okay, so we will build our new hypothesis. That is, the difference will be less, okay, or equal to 0. That means, okay, the current technologies, they may have shorter completion time than the new package one. But today we would like to know, we hope, okay, the new one may have shorter completion time. So our alternative hypothesis would be larger than 0. Okay, and the second step is to specify the level of significance. So based on the question, you will get the alpha is 0.05. So we will compute the value of the test statistic in our step 3. Okay, so the third step, you can follow the formula to calculate out the t-value is 2.27. Okay, you can also check your textbook to get such information from the table. So here you know the t-value, then you would like to check the probability or the real t-value, okay, in to get whether you should reject or accept the null hypothesis. So we will compute the p-value for it. So when you check the t-value table, you will need to calculate the degree of freedom. So based on the formula we had learned before, you can calculate out the degree of freedom is 21.8, and we get 21, okay, as our degree of freedom. So you can check the t distribution with the degree of freedom is 21 to check the p-value. Here you will find, okay, your t-value is 2.27. It's between, okay, it's between the t-value with the probability 0.025 and 0.01 because your t-value is but in such interval. Okay, so we will say the t-value for you with t equals to 2.27 is in the interval of 0.025 and 0.01. Okay, so you will say, will we reject or do not reject the null hypothesis? Based on the rejection rule, if the p-value is less or equal to the alpha, we will reject the null hypothesis. And today what you get, because it's a one-tail test case, so you don't need to double the p-value. Okay, so here the p-value is between 0.025 and 0.01. It's really less than the alpha. Okay, the alpha value is 0.05, so we reject the null hypothesis. Then you will do the conclusion, that is, the research study supports the conclusion that the new software package did provide a smaller population mean completion time than the current technology one. Okay, so that's your result. You can also use critical value approach. That is, you can use the alpha value to calculate the t-value, okay, the interval of the t-value, and to check whether the t-value you have is it located in the interval of the t-value you calculate. Okay, so today alpha is 0.05. So with the degree of freedom 21, you check by the alpha is 0.05, you will get the t-value is 1.721. Okay, so the rejection rule for you by using the critical value, that is, if you would like to reject the null hypothesis, the t-value should be larger than 1.721. Okay, because it's a one-tail test case. Okay, and in your hypothesis, you say, okay, you say you would like it is larger. So if the t-value you get is larger, okay, than a specific t-value, you will reject it. So today you will find, okay, you will find your t-value is 2.27. It's larger than a specific t-value. Okay, so we reject the null hypothesis. Then your conclusion could say that, okay, the study supports the conclusion that the new software package provides a smaller population mean completion time.